Okay. Now I'm done. No. Not like this. Okay. Okay, this is good enough, I think. So much pain. So some of you are probably unhappy with the programming language named C, because some people think about C language as an old language. Nobody is using C programming language. And why are you learning C? Because everybody is using Java or C++, C#, Python, etc. It is not true, because C is a kind of fundamental programming language, and it is still widely used. It is not an old language. It is a fundamental language. It is a basis language for all the others. Therefore, knowledge of general programming becomes incomplete without learning C programming language. Since you are going to be computer engineers, not computer programmers or ordinary website designers, you need to start from fundamentals. That's why we are teaching you C programming language to start with. Later, you will be able to learn all other programming languages depending on the needs of the particular course. Furthermore, it continues to dominate the area of programming. So C programming language is still widely used, and other languages such as C++, C# or Java, or some other languages are actually very close to C programming language. So if you are good in C programming language, other languages are almost the same. So additional things are like libraries, and differences are needed. Gaming applications, anything that requires to work fast, must usually be coded in C programming language, like operating systems, embedded systems, graphical user interfaces, compilers, games, and integrated programming environments. Anything that requires speed issue and low power properties are coded in C programming language, or sometimes C++ programming language. Yeah. Some people say, yeah, some people say that, but it's not important. I mean, it's an historical issue. It is invented in 1972 by Brian Koenig and Dennis Ritchie, which you will have pictures in the next slide. So C programming language is a must-have ability. You have to have it. I mean, you cannot deny the need for the C programming language because you are not just like a regular street programmer. You are going to be an engineer. You are going to be a good engineer. So C programming language is like first learning how to play piano, then play guitar. So in order to learn music properly, music education properly, everybody needs to play piano first. Then other instruments follow. It is still most preferred language for programmers and backend developers. If you make a statistics, C plus C++ is very common. So C is not an outdated language. And furthermore, you can, if you learn C, you can learn other languages over the weekend. So if necessary, you can learn other programming languages. So this doesn't make C programming language is a very comprehensive, full thing to learn, then continue. What you learn is actually, you learn how to program. You don't learn a language. So C programming itself is very short. It is not complicated. It is short, brief. There are not many things. But if you learn programming in a proper way, using C language, then you can adapt yourself to other programming languages because you know all the bases. You know everything at the bottom. It's a fast and efficient. It's fast and efficient language.
Facebook geçen cuma fazla hareketlilik göstermedi. 324 Amerikan doları 76 sent değerinden kapandı.
That's the first time it does something like this. Today also my stereo in my car did not turn off when I take the key out. Radio was still working. I locked the car, it's still working. Came after 1 hour, still working. So I ended up taking the plug out to reset the stereo because it didn't stop. And if I leave it, because I have 4 or 5 hours class, it's going to drain my battery. So I reset it by taking out the fuse from the fuse box, and then it reset itself and turned off. Second thing was internet was off, obviously. We are now connecting through my phone. Electricity is out, and still C programming language is efficient. So it is fast and efficient. Thanks for watching. Thanks for coming to the class. It is easy to extend because it is easy to learn actually. If there are not many things, not many complicated things, it is easy to learn. So what is difficult with C? Since it is easy to learn and it is so simple, making very complicated things requires you to write a lot of things from the beginning. For example, in a language that supports certain libraries for graphical user interface, it could be easier for you to make a graphical user interface in 1 hour of programming. But in C language, it will take longer because that libraries, that pre-written functions may not exist. Actually, they do exist, but some of them, they don't exist. So you have to write your own in those cases. So if you need libraries, actually, C libraries are not limited, but they are more general, so you have to work on them. For popular applications, C libraries are less commonly used because C programming language is used by more professional community. Most people prefer to write their own C program because they have to have the control of everything. Therefore, it's like pencil versus pen. Pencil is more basic. You can write better with pencil, but it has limitations compared to a complicated pen. But complicated pen may have bugs, may have problems, it's more expensive, and blah, blah. So what we do is teach writing with pencil first, then you can use any pen later on. It's a general purpose language. It's a named as middle level language. So it is not a low level language like assembly. It's not a high level language like Python or Perl. It's a middle level language. So as you write C program, you can feel the hardware if you want. Therefore, most embedded systems programming environments provide you a C programming environment for their platform. On top of that, they have special library functions so that you can directly use registers, memory, and other input and output of their microprocessor systems. As you write your C program with those libraries, you can always keep everything under your fingers. But if you are using high-level language prevents you from seeing microprocessor contents, memory contents, or they don't allow you to change them manually because they don't trust you. High-level languages believe that you are not a good programmer, but C believes that you are a good programmer. If it believes that you are a good programmer, there is a problem. What problem is that? Because if you are not a good programmer in C, you may make errors. So you have to be a good programmer in order to write in C because accidents happen, errors can be made by programmers, and it is more difficult to correct incorrectly written programs in C. So you have to be disciplined person. You have to write clean code. I call it as Efendi programming. Where is it? Şey vardır ya, efendi ol oğlum diye. So if you behave properly in C programming, and in any other programming languages, that's true, but it is more valid in C programming language and low-level programming language, because if you don't behave properly, everything will go wrong. It may look it is working fine, but someday or sometime it will fail. So the extension of C programming language is C++ language. C++ language is object-oriented. In the Turkish version, nesneye yönelimli object-oriented programming language. It's more modern. It can allow more people working on the same project. Distribution of parts of the whole business, whole task to different programmers, so that when they bring their code together, it will be easier to end up with a correctly good functioning program. Also, it allows us to make reuse of previously written codes. You have written some library, for example, that library can be implemented as a class, and that class can be later used for other purposes. You will learn those later. Object-oriented means there are objects, such as in the regular programs, there is a CPU master guy, the mechanic in the shop, right? And you give a list of things. You give list of things to do, and he does everything, or multiple CPU, no problem. But there is a list to do. That is the program. Change carburetor, change something, change tire, and then retorque nuts, etc. So there is a list of things to do. It's a program. In the object-oriented approach, there are certain things that are not explicitly defined, such as go get 10 tires. Mechanic, go get 10 tires. You tell to the another mechanic, you don't say how to get tires. You don't say where to get tires. That mechanic, that becomes a class, tire getter. He knows where to get tires. He knows how to get tires. He knows how to ship tires. You don't deal with those. You just say get 10 tires and use those tires. So that keeps the to-do list shorter. And if multiple mechanics require tires, one mechanic says, get me 2 tires easily taken. Another one says, get me 6 tires can be taken. So they don't care the details of getting tires. So that is kind of approach to object-oriented. Where to get tires is previously determined. It is set as intrinsic variable. So class knows it, outside doesn't know it, but object knows certain properties. That's one example. So we will go into structures and functions in C programming language, and combination of structures and functions resulted in object-oriented paradigm, object-oriented approach in later languages, and one of the first ones is C++. It's an object-oriented, highly object-oriented, nice language. It is basically C language with object-oriented extensions and some additional features. So generally, when you ask a person saying that, can you program in C? Can you program in C? And sometimes we get the answer, I can program in C++, but not in C. That means that guy is not also good in C++. Because if you can program in C++, you can program in C, no problem. They are the same language, actually. Diyetteyim, mantı yemeyeceğim, makarna yiyeceğim demek gibi bir fark olur yani. So C programming language book is written by Brian Kernighan and Dennis Ritchie. That programming language is a reference manual. This is a reference manual. No, that's not a reference manual. That's the book. But it is not a book for totally new student. It expects you to be at certain intelligence level, certain understanding, and I believe you are at that level. So you can read that book. It again starts from Hello World, but it explains nice features, nice things, so that it also teaches additional nice information in general for general programming. Today we will go into statements, assignments, expressions, conditionals, and loops with examples. This is our book. There are in many places this book has PDF file, so you should download the PDF file of this book. It's an anonymous book now throughout the world, so you should have it in your probably in your phone all the time. These are the guys. The left is Kernighan and the right is Ritchie, inventors of C programming language and basically Unix operating system. So this is our first program. This is the header. Header file is interesting. In C programming language, there are header files. Header means something that comes before the actual thing. For example, if we say there is a header in a pipe, what is that? The beginning part. There is another piece in the pipe that comes at the beginning, so that it can plug the other pipe. So it's a header. So it is a beginning part that is slightly different, and it allows other parts to continue to merge. That's another file, and that file contains certain information for compiler. Compiler knows what to do, where is the function, what are the constants, and what are the variables of the operation. So stdio.h is required because we are printing something to the output. Therefore, we need stdio. We are doing output here, so output related things must be included to the compiler. There is a compiler thing going on. I am going to explain. And as I said a while ago, there is a main program in each C environment, and in each C program, there's one main, then other functions. So you have to have one main, and one main is accompanied by curly braces. Curly braces indicate where you are in the room. So, for example, I go into class, the curly brace, I exit, curly brace. So in between, I do the lecture. I can talk, I can stand, I can walk, I can do anything I want. But when I exit, I close it. Okay. This thing is also interesting. It is called as a semicolon. It's a delimiter for the lines. Some language, most languages have, some languages doesn't have. To me, it is good to have, because when you say something like, get me 2 tires, okay? So it's like saying okay after every comment. Give me that screw. 16-17 gel bacaklarını kırarım var ya. Sanayi diliyle. Okay, so every time you say something, you end with okay. So for a kind of confirmation. So this is for confirmation to the compiler. Compiler understands that you said something and that is finished. So the thing comes after that is a next expression. Each expression is delimited by semicolon. In some languages, it is colon. In some languages, it is dot. You can put a check mark if you have such a character. So, yeah. Ne yapmaz? Oluyor. That is the beauty of it. So this is interesting. You have a file named as hello.c. In computer world, files have extensions. Why do we have such extensions? Because operating system classifies, most operating systems, not all, most operating systems classify files and associate file types with extensions. Is it necessary? Yeah, that's a convention. Is it a must? Yes. But is it a scientific must? No. We decided it. If we make our own compiler that accepts files that are not with C extension, it could be P extension, that can work, or without any extension. Extension is a good thing, right? So we have extensions. So it's a kind of old-fashioned, coming from the early years of programming. Type of programs were determined by the extensions since more than 50 years. So we still use extensions. So compiler is a program. Compiler is a program that takes your file like a mail, like a piece of input, and compiles, executes, and creates an executable code. And for Unix environment, the name of the file is always a.out. So a.out is the compiler's output, and the compiler can be PC, hello. Let's see. This is the command that you implement in order to compile it. So cc hello C. CC means C compiler. It's an application. So compiler program is CC. There is also GCC, GNU C compiler. GCC is also available. Another C compiler implemented by another foundation of Unix. So executable machine code file is generated from text file that contains commands in C language. So C language is translated to machine language. Machine language file, machine language instructions, just like you know how to program in assembly language, zeros and ones, 3A, 05, etc. So these are in a.out files. So when you run a.out, such as a.out, enter, it prints hello world on screen. How to print on screen, where is the screen, those information are actually in stdio.h. So you can look up stdio.h contents from the internet after you exit from this class. That's given as an exercise. Check what is inside stdio.h. That's not a homework, that's an exercise. So you do it, you say okay, and you are done. Don't send it to me because I know it. There is a number sign here. We call this as number sign. These are compiler directives. So if we go back to machine shop, and in the machine shop, assume that there is in a Turkish machine shop, there is a French person, French mechanic. So you give list to do change tires, fix engine, change windshield, etc. Certain list in Turkish. You give it to guy doesn't understand. So you need a translator, Turkish guy. That is the compiler. So you can tell to compiler some other things that doesn't go to French person, such as tell him to pay attention to my car more than others. So you tell that to the translator. You don't include that into the commands. That's a communication between translator and you as a car owner. Okay? So those are not to-do list items. Or you can say, make sure that car finishes before 5 p.m. Don't tell that to the mechanic, you tell that to the translator. Those kind of things. So we say those things with number sign in front, and those are named as compiler directives. So that is the communication between compiler and the person. Compiler and the person who write the code, the C code. So compiler behavior control is performed. Those behaviors may affect output, but those commands has no machine code equivalence. These doesn't have machine code equivalence. These affect how machine code is generated. Is that clear? Etkiliyor aslında. Ama içine girmiyor. Another example is when you go to restaurant, you interact with waiter. You say we are 5 people asking for Adana kebab, etc. And one of you says, mine will be well done, pişkin olsun. Okay, so waiter keeps that in the brain and controls the operation of the cook, but it doesn't go into the definition of how to cook Adana kebab. Adana kebab is still cooked in the same way. Result is affected, result changes, that kebab is different, but actually cook's procedure doesn't change. So actual program is affected So there is an effect, but it is not translated into the formula of kebab. It changes the behavior of food coming. So it is a communication between the person and the waiter, not the final code.
Gerdan deyince daha fazla pişirmiş olmuyor mu?
Oluyor ama Adana kebap yine Adana kebap oluyor. Yani garsonla arandaki hesap. Veya sen iyi pişkin diyorsun, garson hiçbir şey yapmıyor belki de. He he diyor sana. Yani şey değişmiyor. Koda giren bir instruction'a dönüşmüyor. So this is a translation from C language to from C language to machine language. But when you have compiler directive, that line of code is not translated. It is used in translation. You can say to the mechanic guy, çok sinirliyim, ona göre. So how it is translated? It is kind of priority is changed. So it is not to-do list at the end. It is not in the to-do list.
Doesn't see that. CPU doesn't see that.
CPU doesn't see that. Yeah, at the end, CPU doesn't know it. CPU will execute. CPU will execute the resulting machine code. So the resulting machine code is affected by the compiler. So how it is affected is determined by the compiler directives. Yeah. Yeah, it changes the code, but it does not go in the code. It changes how you construct the code, and therefore the resulting code changes, will be different. But in terms of translation, there is no translated version of include stdio. So everything will be converted to, for example, add 5 code R1 there. So, but this doesn't have anything. So translation result does not exist. There are in Hello World, there are codes. Some of you are familiar with that. It's a text string. So if you have a text string, series of characters, it can be delimited with, it can be indicated with quotes, double quotes. And also there is a backslash n here. In the old days of computing, remember there was a teletypewriter. In one city, one person is typing. In the other city, typewriter is typing the telegraphs. So it is teletypewriter telegraph. For 60, 70 years, that was the standard telegraph in post offices rather than Morse alphabet. Morse alphabet quickly became obsolete, and they moved to teletypewriters. The dactylo in the old Turkish name. The endpoint prints, but the keys are on the other city. So you type from one city, it is printed in the next city. Obviously, in order to see what person is typing, there is another punch card system, paper system, in the sending city as well. So 2 printers, 1 keyboard, let's say. You type, and you go back. what is the mechanism in the typewriter? There is an arm, right? You hold the arm and go back. Or there is a tab key, and you press tab key, the whole paper moves a little bit. So backslash n is actually that arm in the typewriters. When you press backslash n, that means you finish typing and you are on the next line. Next line. When you hold next line arm, the paper drum rotates a little bit. If you have typewriter at home from your grandfather or grandmother. Backslash n, therefore, indicates that that piece of line is finished and you are in the second line. Those are control characters. Go back one character. Ring the bell, ding, or increment 4 characters at once, which is tab. How about backslash character? Backslash character itself, if you want to print backslash character itself, you use backslash backslash. Backslash backslash means I am really trying to print backslash character now, not something else. Backslash n is the new line. Backslash t is tab. Backslash p is back. What is back? For example, you print one. After you print one, when you print this one, you go back to the same position for correction maybe. So go back one character means backslash p. Yeah. Backslash backslash n. This backslash will be escaped by this, so this will print. This will print backslash. This will print n. So backslash backslash n will print backslash n. And obviously backslash backslash n is necessary because after you type, you have to print enter to send the signal to the other paper in the other city saying that I am finished and show the line. So it has to end with backslash n, otherwise it may not appear. C programming language and other programming languages have buffers inside. Those buffers are filled as you type and cleared, finished when you press enter at the end of the line. So it's like carries return for the next line. If you don't print backslash n, it may not appear on screen. It may or may not. Usually not. Any questions?
I add another backslash if I want to print backslash.
Yeah, that here. Backslash n is printed now. This backslash n allows us to print that thing. You can have, instead of having one line, you can have hello world. Huh? Who? Yes, go ahead.
Teacher, what will happen if we write multiple times backslash b?
Multiple times, you go back multiple times. It is like moving the cursor backwards multiple times. You move one, another time, another time, another time, another time. So you can go back in the existing line, just like in the typewriter. Is that clear?
Yes, thank you.
You can erase complete line, then write something else. But once you print backslash n, backslash b doesn't work for the previous line, or for the screen. You can only go back to the beginning of the first column. So you can have the same thing in 3 lines. Each line ends with semicolon. This is space. Printf is used. It's a function. I haven't teach you functions yet, but those are functions, and functions are usually called in this way. So function name and the parentheses. Inside the parentheses there are parameters, and if I am done with the execution of the function, I can have other things, but if I am done, semicolon. This is easy. One example from the Kernighan-Vichy book is, it's a classical example in American books, because Americans use Fahrenheit and they are very curious about how centigrade is around the world. So one famous example is conversion between Fahrenheit and Celsius. Do you know how Fahrenheit is formed? It's actually minus 32 degrees to 12 degrees. This is the freezing point of alcohol with water. This is boiling point of something, boiling point of the water. Okay, they divided that range into 180. So they divided boiling point and the freezing point of alcohol into 180, and they developed their scale, totally different scale. So conversion formula is here. Centigrade version is actually 5/9 times Fahrenheit minus 32. So some shift and some scaling. So our task is to write a program that converts Celsius to Fahrenheit. So these are the inputs, and these are the corresponding Fahrenheit numbers. So for example, 40 degrees Fahrenheit is 4 centigrade. 100 degrees Fahrenheit is actually summer temperature, 37 degrees. Obviously, there is a formula here. So we are going to write this formula to our program. Let's see. So this will be the output. This program, this C program converts Fahrenheit values to Celsius. There are interesting parts. First, these are used for commands. A good program requires documentation. As I said, Efendi programming, write what you are doing at the beginning of the program, write your name as a programmer, write explanations. So those are the text parts that does not go into translation. Those are just explanations. They are not even compiler directives. So the waiter in the restaurant does not understand that. But that's for yourself to remember later, or someone else. So this program converts, prints Fahrenheit Celsius table. It's not conversion, basically. It's a equivalent. It's printing this table. Conversion, but conversion of these numbers. So this is explanation. The main program is here. There must be one main, and since we are beginners, we have the main. Let's start. So describe, define variables, Fahrenheit and Celsius. These are variables. What kind of variables? Integer variables. Other variables, lower, upper, and step. Those are also integer variables. So I have now defined 5 variables to work on. Then I will assign numbers to those variables. That is what assignment is. Assignment. Lower is equal to 0. Can I write 0 is lower? No. This is because 0 is 0. This question and this mistake can be done by first class students. I can understand that kind of feeling, and some of you did that last year. Maybe among you there are people who thinks, why not? Because compiler is a very dumb guy. It just starts from the beginning and reads one by one. So when it reads lower, it's an first it reads integer lower, so lower is a variable. If he sees lower again, it thinks that you are referring to the variable you said in the previous line, which is integer. So when our compiler sees this, our compiler goes back to the list that lower is an integer. So probably you guys are talking about an integer, right? That and it sees an equal sign, then he understands that you are, as a programmer, are going to set a value to that variable. So it understands you one by one. Then it sees 0. So lower variable becomes 0. So if you say 0 is equal to lower, just like mathematics, it will see, because it is going to see from the beginning, reading one by one. 0 doesn't mean anything to him. Is equal to 0 cannot be equal to something, because 0 is already known value. So human cognition may accept 0 is equal to lower, but actually compiler understanding expects everything coming from the left side, L value, left value. Therefore, we say lower is equal to 0, upper is equal to 300, step is equal to 20. So in order for compiler to understand this line, step must be defined. at the top. Otherwise, when I say step to the person, it will give me an error. What is step? He doesn't know. Therefore, must be defined at the top. Then here comes the logic. There is a step size for printing. 100, 120, 140, 160. So I am going to keep one counter. I am going to add 20 at each time. Add 20, add 20, add 20. Then find the corresponding Fahrenheit and print both. So now I am going to make a loop. Fahrenheit is less than upper. What was upper? 300. What was Fahrenheit? Lower at the beginning. What was lower? 0. So while Fahrenheit is lower than upper, at the beginning it is Celsius value is equal to 5 times Fahrenheit minus 2 minus 32 over 9. Why don't I use 5 over 9 times why don't I do this? Because these are integers. When I make integer divisions, 5 over 9, the result will be 0. Because computer will try to find an integer nearest that matches nearest to 5 over 9. And 5 over 9, if you do direct division, it will give me 0. So everything will become 0. Therefore, I will first obtain a bigger number, then divide the vector by 9. For regular mathematics on paper, that's not important. But for computer, it is important what you do first. For example, you divide 0.1 by 10 to the 50. Then multiply it with 10 to the 50. So if the computer resolution is not good enough, you may lose certain details if you divide this number by a big number. I'm just making it up. So it doesn't matter after you multiply with the same number, the result will be 0.1. So this part becomes lost because you hit with a so big impact, details are lost. Resolution, number of bits are limited in computers, in registers. So in those cases, it is better to interact big numbers among themselves first, so that the resolution is still preserved. Similarly, I don't perform 5 over 9 first. I multiply this with 5, then divide it by 9. Then I will get some meaningful number rather than 0. Because this becomes 0 as soon as you do. But if you say float instead of integer, then this is okay. Yes. Someone turned on the microphone.
Can I ask a question?
Yes, you asked.
The 5 over
9.
No. 5 times Fahrenheit minus 32 over 9 can't be integer sometimes too. So it's not always integer.
Yeah, it is rounded. It is rounded to integer. The system rounded. So since Celsius is integer, at the top it is defined as integer. When you put equal sign here, at the place of equal sign, it is rounded to nearest integer.
Ha, yani float desek de olur muydu peki ona?
Olurdu.
Ha, tamam hocam.
So once you calculate Celsius, you print %d tab %d and what's going on? Fahrenheit and Celsius. This part is formatting. Printf is actually, this F is for formatted print. When you say %d, that means a decimal, a digit is going to be printed. Digit is going to be printed, and then a tab will be printed by then another digit will come and new line for the next line. What are those digits? First is digit 1, second is the 2. So first %d is actually Fahrenheit, second is actually Celsius. As the while loop goes, Fahrenheit is incremented. Fahrenheit is equal to Fahrenheit plus step. What was the step? 20. So we start with 0. Next Fahrenheit is 20, and the procedure is repeated. Do you understand?
Why did they backslash D?
Because we want space in between. Then it will be like this. 17 will be closer to 1 because 1 has 1 digit and 20 has 2 digits. 100 has 3 digits. This part will become close. Upper part will become closer to first part, so it won't be straight. We could have used space, but actually we will try. It won't look as good. Verelim. Bir dakika. Commenting is very important. Comment is very important. You can have C-type comments, slash, star, star slash. That's the C-type comment. In C++ style, it is slash slash. In C plus C style, you can have slash star, many lines in between, then star slash. So many lines in between can be commented like a parenthesis. This is the comment explanation paragraph. In C++, you have to put double slash in front of everything, all the lines. So for C, in C++, C-type commenting is also acceptable. The advantage of C-type commenting is when you have a paragraph, a piece of code, you want to exclude it from the compiler. Just put these two from beginning to end, then anything in between is excluded from compilation. Sometimes you have two codes. This is version 1, this is version 2. You are trying to make your homework. Version 1, so version 1 is working, but you want to copy certain information to version 2. in the same file. You don't want to lose the first part, so just comment and write your main program here, and your old code and old way of doing things can stay for reference, for looking. If it was, and if you want to go back to the previous one, just delete these and put comments up here. Now upper part is now your program. The lower part is comment, so ignored by the compiler. For C style, you have to go through all the lines with slashes. It is more tedious. It is harder to do for multiple lines. But for explanations like this, instead of using before and after, right, you can just use slash, and the right side is free. For that purpose, double slash comments are good for single line comments to the right side. It is easier for writing single line comments. You can write multiple lines, but put those comments to all the lines. Let's give a break and so continue. Yeah.
Main'den önce hiç kullanmamız gerekmiyor. Ben yazarken öyle öğrendim. Kendi programında int ile beraber yazıyordum.
Global değişken oluyor.
Evet.
Global değişken oluyor. Global değiştirenler. Başka fonksiyonlarda kullanırsan o fonksiyonlarda da geçerli oluyor netice. Yani sen dedim ya kapıdan geliyorum diye, sen koridorda tanımlıyorsun değişkeni. O zaman o diğer sınıflara da geçerli. Mesela ben Fahrenheit dedim ya, dışarıda dersen başka bir yerde Fahrenheit başka bir işe yarıyorsa onu da değiştirirsin.
Her yerde kullanılmak için.
İyi bir şey değil o. Global değişken değil. Karıştırır şeyleri, işleri karıştırır. Çok önemli yapabilirsin ama.
Peki yani ben onu silindiğiyle çalışacak mıyım?
Çalışmaz. Onu içeri yazacaksın.
Hayır, ben o baştaki int'i de silsem benim yine yazdıklarım çalışacak mı?
İçeri yazsan çalışır.
Hocam, bu kodları ID kullanmadan nasıl çalışıyor?
ID mi? Nasıl? Ne
Mesela
ID'si?
Xcode, Visual Code falan kullanmadan.
Ha IDE.
Hmm.
IDE. Konsoldan çalıştıracaksın zaten.
Hocam sorabilir miyim?
Evet sor. Dinliyoruz. Gayet
Hocam
iyi.
evden ben kendim deniyorum da şu anda. Main fonksiyonunu tek başına kullandığımda compile'lamıyor. Başına integer koymam gerekiyor. Bir de return zero yapmam gerekiyor.
Int main koyabilirsin, evet. O GNU compiler'ın şey yapmayabilir. ANSI compiler'ına GNU compiler'ın int isteyebilir. Doğru söylüyorsun.
Tamam, teşekkür
Ben
ederim.
değişkeni söylüyorsun zannettim.
Hocam ben bir şey sorabilirim.
Tabii.
Niye main'i print'ten sonra yazdık? Print Fahrenheit Celsius şeyinden sonra.
Main'i
Print Fahrenheit Celsius table yazdık ya.
evet.
Ondan sonra yazdık ya main'i. Niye öyle yaptık?
Açıklamayı genelde yukarı yazarsın. Aslında include'un da üstüne yazabilirdik. O etiket, yani dosyanın etiketi. Açıklamalar. Kodun kendisiyle bir alakası yok.
Tamam hocam, teşekkürler.
Ben bir şey anlamadım. Backslash'e bastırmak istediğimizde
Evet.
Printf'in içine nasıl yazacağız onu anlamadım.
Backslash n. Yapalım şimdi, dur. Hello bu. En büyük fener. Hasan'ı şey yapmışız.
Hocam diğer ders canlı yayınlanıyor muydu?
Ne?
Diğer ders canlı
Yayınlanıyor.
İlk 151.
Bitti mi bu ders?
Hayır.
Buradaki insin, bu ins gerekli bir ins değil mi?
Void de edebilirsin diye. Void diye.
Evet, içine void parantezin içerisine yazılmıyor muydu int'ten sonra?
O başka void.
Hocam main'siz de bir fonksiyon vardı. İnternette dolaşıyordu main'siz yazdım diye ama. O main'siz nasıl yazıyorlar ki?
Bir dakika. Ya onlar doğru şeyler değil. Çalışıyorsa
Ama
bile.
çalışıyor hocam.
İşte bir hata bulmuşsun.
Hayır, burada hayır ben böyle yazmadım. Ben virgülden sonra 4 yazmadım. Hayır. Ne ya? Kızım, ben
Tamam mı? Yazdım bunu.
Bir şey soracağım. Ben tekrar.
Hello once dedik.
WP Linux'tan
Bak şimdi Linux.
oradan geliyor.
A.out nerede?
A.out.
CC Hello one. Hello one yazdık mı biz?
Bu en son yazdığımız hello one'dı.
Evet hocam en son yazılı.
Ha bak hello one CC hello one.c dedik. Void'i sevmedi. Int olsa daha iyi dedi. Ama gene yaptı. Tamam mı? Void eski usul yani. Şimdi
Çıktığı vermedi ama değil mi? Şu an.
ben çalıştıracağım şimdi. A.out diyorum. Pardon şöyle yapacağım. Çıktığı verdi. Şimdi şey yazdırayım. Backslash'e yazdırayım.
İki tane backslash arka arkaya tekrar anchor etsek bir tane backslash'tan basar mı?
Bir daha backslash'e koymamız lazım.
Arasında boşluk olacak mı peki böyle yaptığımız zaman?
Hayır, backslash'ini basacak, ondan sonra da basacak.
Yok ben şey diyorum, ikinciye de iki tane backslash koysak. İki backslash'ın arasında o zaman boşluk olacak mı? İki tane backslash
İki tane yok ki burada, bir tane var. Biri gerçekte olması gereken backslash'ten, biri ekrana basacağım backslash'ten.
Tamam ben de diyorum ki ikinciyi de basmak istesek.
Bir tane daha koyman lazım.
Evet ben ondan şey olacak mı diyorum şimdi. Arada hani biz o fazladan bir backslash kullanıyoruz ya, oradaki boşluk olarak mıyız?
Yok tamam anladım. O zaman iki tane backslash'e basalım.
Evet.
O zaman bir tane daha koymam lazım şuraya. Ay.
Tamam ben anlamışım.
Bir daha. Bunu mu diyoruz?
Evet şimdi acaba bu backslash'lar bitişik mi olacak?
Bakalım. Gene CC diyorum. C Compiler. Hello one.c diyorum. Compile etti. Warning'i geldi. Warning'i düzeltelim. Aslında onu da düzeltelim. Hadi. Şunu int yapalım.
İnt yerine keşke kullanabilir misiniz burada?
Ya, int diyelim. Boş ver.
Yok hayır bunun için demiyorum. Dosyaya girerken. VL yazıyorsunuz ya. Linux için.
Diyebilirsin. Ama dememen lazım. Bak geldi. Bu sefer hatasız, tamam mı? Çalıştırıyorum. Çalıştırıyorum.
Araya boşluk verme.
Ne yazık o?
Hocam, derse nasıl çalışıyoruz? Önceden anlattığımız konular hani sözler gibi. Şimdi detaya ineceğiz.
Sözel devam edeceğiz. Sözel de devam edecek. Karışık gideceğiz.
Yani detay olursa çok detaylı olur. Eğer detaya inmesek
Kitabı okuyun. Ezber diyeceksin. Kitabı okuyun. Kitabı okuyun. Ödevleri yapın. Labı yapın.
Link'te de mi C devam edeceğiz yoksa? Link'te de mi C devam edeceğiz?
Ne dedin?
Bundan sonra 2 saatimiz var ya, orada mı C devam edeceğiz?
Anlamıyorum. Yüksek sesle konuş.
Bundan sonra 2 saatimize de mi C devam edeceğiz?
Hayır. Otur.
Tamam.
Hocam bir error yazdırabiliyor muyum?
Hazırız.
Yani fonksiyonu var mı onun? Yoksa başka bir şey.
Gerek yok. Nasıl yazdıracağına kendin karar ver. So, what we do is in C, all variables must be declared before they are used. Declaration saying that I have a variable. The compiler says, okay, this guy has a variable and allocates memory for that variable. 32-bit, 16-bit, 64 bits, etc. In some other languages, you don't do it. In some other languages, you just say A equals to 5. When you say A equals to 5, the system automatically assigns an integer or floating point number or double precision number for you. But in C, you have to declare it. You have to say, I am going to use this type. It's a typed language. Some languages are not typed, so there are flexibilities. For example, you say A equals to 5, and then say B equals A plus 0.5. What happened? You didn't say anything. This is not C. You didn't say anything in advance. So when you say A equals to 5, the compiler thinks it's integer, allocated integer memory. But you added a floating point number after that instruction, after that line of the code. Then suddenly the system should change it to the floating point number because there is a 0.5 there. That's possible. But what if you want actually, if you add 0.5, you want B to be 5. meaning that you add 0.5, it is still 5. In that case, B should be integer. So C allows you to have control over these issues. You have the control. The problem is, it is like shoes versus slippers. If your shoe size does not match, you have a problem. So if you use incorrect variable for different types of data, you will have an error. But if you have flexible language in terms of declarations, then performance is little bit worse, but flexibility gives you certain freedom and ease of programming. You don't forget, and if things become more complicated, system automatically adjusts variable type to float or double or whatever. So certain things are handled by the interpreter or the compiler in some languages, but in C, you have to declare it. This is integer, this is character, this is string, this is floating point number. You have to declare it before you use it. Okay. So a declaration is, announces the variables. This is declaration. Int is declared Fahrenheit Celsius. Another declaration, lower upper step. Do I have two lines? Do I have to have two lines? No, done it in one line. Or I could have done it in 5 lines, one by one. So it is kind of flexible. You can have commas for declaration. These declarations actually tells compiler to allocate memory for the coming operations. So it is for memory allocation. What is the variables? Variables are floating point, anything that can be changed. So when I say variable in mathematics, it is X, Y, Z. These are variables, P, Q, R. If it is integer, I, J, K, etc. So these are variables where you can set the value. In order to do that, computer should allocate memory. It could be 16-bit integer. It could be 32-bit integer. It could be 8-bit character. 8-bit things are characters. I can say unsigned int. When I say unsigned int, there are no negative numbers. So leftmost bit is discarded. It is used for numbers. So instead of minus 32,000 and plus 32,000, you have numbers between 0 and 65,000 if it's an unsigned integer. Unsigned int k, for example. Common data types. Common data types are integers, floats, characters, short integer, same bit, long integers, double precision. Long integers is actually very, very long. These implementations may be different for different platforms. For 64-bit architectures and 128-bit architectures, the integer can be different. So that is defined in compiler headers. What type of machine you are going to target. Same program can be compiled to different platforms, and each platform, at each platform, you end up with different assembly language, and that is determined by the compiler. So it may work differently, especially long and int may work differently for platforms that are relatively new to the environment. If you have a very new computer, new processor, you need to check whether the integers are at the same size, whether it makes a problem. It makes a problem with pointers and pointer arrays. For regular programs, it doesn't make any difference. For interpretation, it may make difference. There are also arrays, structures, unions, pointers, and functions. Structures and pointers and functions give way to object-oriented programming. Actually, functions are very fundamental to everything is function. You cannot write everything in one main program. You will implement functions and call those functions from your main program. This is assignment I was mentioning. Lower equals to 0, upper equals to 300, step equals to 20. It can be done in the single line. Lower is equal to 0, upper is equal to 300, step is equal to 20. Not with commas, with semicolons. So this is one business, this is another business, this is another business. So three things going on. It could be at the same line, but limitations, delimiters must be present, must be there. You can have this I equals j equals k equals 0. All of them becomes 0. So it propagates from the right side. This becomes k becomes 0. Then the value of k becomes j, which is 0. Value of j becomes I, which is 0. These kind of things are not suggested because it makes your program less understandable. So write most of the things in a long way. For example, let's say int I equals to 5. This is good. You can say int I equals to 5 as well. So it's also good. But if you see this, again, int k equals to 5, understandable. Int I equals to k equals to 5, it's less understandable. Still valid. Make your program understandable by others and by yourself after 1 month. Loops. Okay, let me finish this. In the previous program example, we had a loop. So it's basically a flow. You go here, you check for a condition. If the condition is true, you execute inside. If the condition is not true, you finish. So if this is true, you execute and go back. Check again, execute, go back. Check again, execute, go back. So what if you say while 1. It's an infinite loop because you cannot change 1 here. So inside there must be a test, or you can have something like this: while check. What is that? Check is a variable. Inside somewhere check is equal to 0. Make check is equal to 0, and then with some condition, then in the next check this will fail. So you don't have to make tests. You don't have to make tests in the parentheses. You can create a variable, put that variable into test, while checks whether check is 0 or non-zero. If it is 0, it fails. If it is non-zero, it continues. Or you can make the test inside the parentheses. It's more widely used. Otherwise, you continue. Yeah. Evet. Çıkamazsın o zaman. Çıkamazsın. Sonsuza kadar, ebediyete kadar dönecek. Ne? Because, good question. Because what you do here, is a test. It's a test. You either do test there, and the result of the test, for example, temp is equal to, it's double equal. Single equal is assignment, double equal is test. It says whether. Temp is equal to, is it equal to 30? Right? Say if. How do you check this? What is checking? Good question, actually. What is checking? The thing is, your runtime system, the microprocessor, this is actually converted to an assembly language code. But even if that assembly language code must be executed during runtime. During runtime, temp is a variable. What is temp? Let's say it is 30 in the variable. You read it from somewhere, you read it from user, it is 30 somewhere. Now you come here. So what happens is it should go. It should continue because it is correct. But what is being checked here? Temp is equal to 30 is a logical statement. It is true or false. So if 30 equals to 30, if temp is 30, this becomes 1. If it is not, for example, if it is 29, it becomes 0. If it becomes 0, it means if 0. If 0 means don't go in. If 1 means yes, go in. So you do an expression, you evaluate the expression here, check the result, whether it is 1 or 0. It could be non-zero. Non-zero is also, for example, 5 is also true. 1 is true, 5 is true, 6 is true, 0 is false. Okay? So if it is, let's say, while 1 continues forever, because you cannot check it. You can say while I, the variable, I, for example, I is I minus minus. I is equal to 10, while I, what happens is, in the first trial, it becomes 9. In the second trial, it becomes 8, 7, 6, 1, and 0. When it becomes 0, it finishes.
We don't explain what is temp.
If we don't
Explain what
it,
is temp.
you have, it's a C language, you have to declare it at the beginning, int temp. If you declare it but forget to set it, if you declare it but forget to set it, like here, you set int lower, you set int lower, but forget this, it is still 0. So if you create a variable, it is set to 0. If you use it, it becomes 0. If you don't create it, it will not compile.
Can you leave instead of while anytime you want?
If only does once, while is a loop. So if you want to, if you want to execute, multiple times, you will either use while loop or for loop. For loop I am going to do tomorrow. If is only valid for one time. If it's interesting, if condition is satisfied, you do it. If condition is not satisfied, you don't do it. If condition is satisfied, you do it. Not satisfied, do something different. Not both, which is else. Again, pay attention to parentheses. So it determines the region of operation. These are going to be done if the condition is not satisfied, and these are going to be done if the condition is satisfied. And the flow chart is on the right. Logic flow chart.
If you use else without it.
If you use else, it doesn't work. If something is true, blah blah, and again, you can put another if inside an if. If your shoe size is 42 and you don't wear socks, and if you don't wear socks, you should take this shoe. Otherwise, doesn't matter. You do this. If it is not 42, you do this. Otherwise, this. If nothing happens, this. A concentrated version has else if. Because else J equals 0. You can have this. So this is a statement. you can replace, actually what is happening is we are replacing this with two curly braces and write a code in between. Therefore, this is also legal. If j equals 0, double equal, j equals 0, not here. If j equals 0, k equals 1. This is okay. So you don't always need curly braces if you have only one line. So if j equals 0, k equals 1, same thing. So these two are same thing. Curly brace actually helps to distinguish only if you have one line of expression. If you have multiple lines of expressions and statements, etc., then statements you need to use curly braces because you have more than one semicolon. If you will have only one semicolon, just write next to it. Let's stop here and continue tomorrow. If you have any questions, let me know.
J'yi karakter olarak 0 yapsak yine yanlış verecek değil mi?
0 yaparsan bu çalışacak. 0 yapmazsan çalışmaz. Ha? İşte orada sıkıntı çıkabilir. Karakter 0 başka bir şey çünkü.